March 29, 2026, a Sunday. A satellite called Starlink 34343, one of over 10,000 Starlink satellites currently in orbit, is flying at an altitude of 560 kilometers above Earth. Then, without warning, it stops communicating. That alone would be a minor footnote. Satellites malfunction sometimes. But moments later, an independent radar network called LeoLabs detects something unusual in the data. Tens of objects, appearing out of nowhere, in the exact vicinity of where Starlink 34343 was. Not a gradual degradation, not a slow failure. A sudden fragmentation event. Debris where there was one satellite before. And it happened just 3 days before Artemis II launched to the moon. Let's be precise about the facts, because this story got a lot of dramatic coverage, and some of it was exaggerated. Starlink 34343 was launched in May of 2025. It was orbiting at approximately 560 kilometers altitude as part of SpaceX's V2 mini-optimized model, the latest generation of Starlink satellite. There are currently 3,532 of that specific model in orbit. On March 29th, it experienced what Starlink officially described as an anomaly on orbit resulting in loss of communications. Very carefully worded. LeoLabs, a private company that operates a global network of ground-based radars specifically designed to track objects in low Earth orbit, characterized it differently, a fragment creation event. Their radar systems immediately detected dozens of objects around the satellite's last known position. The working hypothesis, according to LeoLabs, the event was likely caused by an internal energetic source, meaning something inside the satellite itself, rather than a collision with existing space debris. That phrase, internal energetic source, is doing a lot of work. In plain language, it means something on the satellite either exploded or violently vented. The most likely candidates are the propulsion system, the satellite's fuel tank, or possibly a battery failure. LeoLabs noted this incident appeared similar to one that occurred back on December 17, 2025, involving a different Starlink satellite, number 35956. In that earlier incident, a rapid venting of the propellant tank caused the spacecraft's altitude to drop suddenly by about 4 kilometers, and released a small number of trackable fragments. Two similar events. Same symptom pattern. 3 months apart. Same type of satellite. And SpaceX has not publicly disclosed the root cause of either incident. There's a concept in orbital mechanics called Kessler syndrome, named after NASA scientist Donald Kessler, who described it in 1978. The scenario: if the density of objects in low Earth orbit reaches a critical threshold, a single collision produces debris that causes another collision, which produces more debris, which causes more collisions, cascading, until certain orbital altitudes become effectively unusable. Not for years, for decades, maybe centuries. Nobody is saying we're there yet, to be clear. Experts who study this say full Kessler syndrome in low Earth orbit is still unlikely in the near term. At altitudes below 600 kilometers, atmospheric drag will pull debris back down within a few years, so the environment is somewhat self-cleaning. But unlikely near-term and zero risk are very different things. When the December 2025 Starlink anomaly happened, Starlink 35956, analysts at LeoLabs noted explicitly, these events illustrate the need for rapid characterization of anomalous events to enable clarity of the operating environment. When it happened again 3 months later with Starlink 34343, astrophysicist Jonathan McDowell, who tracks space activity and is formerly of the Harvard-Smithsonian Center for Astrophysics, said something important. I don't see how the risks can be nil. They are low because all the debris is expected to re-enter quickly, but I'd like to hear more about why they assess the risk to be zero. And then he added the part that should give everyone pause: if the fragmentation event arose from a design flaw, McDowell says, that could affect hundreds of Starlinks, and then the risks go up a lot. There are 3,532 of the exact same model currently in orbit. Here's the timing that made this story especially nerve-wracking in the moment. Starlink 34343 broke apart on March 29th. Artemis II was scheduled to launch on April 1st. 3 days later, SpaceX said publicly that the debris posed no risk to the ISS, its crew, or the upcoming Artemis II mission. They proceeded with a Falcon 9 launch of a different mission, Transporter 16, just hours after issuing that statement. But the debris was real. LeoLabs tracked it, and debris in low Earth orbit doesn't politely move out of the way. At 560 kilometers altitude, debris moves at roughly 7.6 kilometers per second. That's faster than a rifle bullet by a factor of about 20. A piece of debris the size of a marble, traveling at that speed, carries enough kinetic energy to punch through spacecraft shielding and destroy a satellite. A piece the size of a paint flake can damage a window. The Artemis II launch trajectory passes through low Earth orbit on its way to the Moon. SpaceX's confidence that the debris would deorbit quickly, within weeks, given the relatively low altitude, appears to have been correct. Artemis II launched and encountered no debris-related issues, but the margin of comfort there was measured in days, not months. The two Starlink anomalies, December 2025 and March 2026, have triggered something important. They've forced a public conversation about what happens when a fleet of 10,000 satellites has a recurring failure mode that nobody has officially explained yet. SpaceX announced in early 2026 that it would lower the orbits of approximately 4,400 Starlink satellites, moving them from around 550 kilometers down to 480 kilometers. The rationale: shorter deorbit times for failed satellites. If something breaks down there, atmospheric drag brings it back faster. The debris window shrinks. That's a responsible move, but it's also a signal that the company knows the orbital environment is getting harder to manage. Meanwhile, the crash clock, proposed by scientists in December 2025, is being discussed as a formal environmental indicator. It stands for Collision Realization and Significant Harm. It's essentially meant to function like a climate metric, a continuous estimate of how close we are to a tipping point in orbital debris. The idea is sobering. We currently only avoid catastrophic cascading collisions because satellite operators are performing constant, active avoidance maneuvers. If those maneuvers stop for 24 hours, due to a solar storm, a cyber attack, or a communications failure, the math changes dramatically. Starlink 34343 didn't crash into anything. Its debris will mostly be gone within a few weeks. SpaceX is investigating. Life goes on. But zoom out for a second. In the span of a single week in late March 2026, a satellite unexpectedly exploded in low Earth orbit, scattering debris into one of the most congested highways in space, and the world's most high-profile human spaceflight mission launched through that same neighborhood 3 days later. Low Earth orbit right now is like a highway that was designed for 100 cars, and we're trying to run 10,000 through it simultaneously, at 27,000 kilometers per hour, with no lanes and no traffic lights. Just software. And math. And the constant assumption that every satellite will behave as designed. Starlink 34343 reminded us what happens when one of them doesn't. And the question that hangs in the air, the one SpaceX hasn't answered yet, is, was this a random one-off failure? Or does the V2 Mini optimized satellite have a design flaw that's waiting to repeat itself? Across 3,532 identical satellites, simultaneously, we don't know. SpaceX hasn't told us. And that silence, in the most crowded sky in human history, is worth paying attention to.